Welcome to VMblog's 2022 Mega Series, and today we have the pleasure of speaking to Patrick Bergstrom, the Chief Technology Officer at StormForge. Thanks for joining us today.
Hey, thanks for having me, David.
We're glad to have you.
So maybe you can start by telling us a little bit about the company and kind of, where does it fit into the Kubernetes space? Including containers as a technology and DevOps as an IT discipline?
Yeah, so excellent question. At its core, StormForge is actually a machine learning organization, and Kubernetes is not where we started, which I think is really interesting. We actually started leveraging machine learning to optimize physical data centers to reduce power consumption and reduce carbon footprint of organizations that are running physical data centers at the enterprise level. And we did all of that running our own workloads and our own compute on Kubernetes. And so we actually took those algorithms that we designed and we turned that around on our own Kubernetes installations in order to reduce our cost while at the same time increasing the performance of our applications. And we just kind of stumbled into it, and it worked really well. And we figured out that it was something that we could offer as a service, and we just kind of put it out there and said, hey, is anyone interested in this? And unsurprisingly, we got a huge response out of that. So when it comes to, Kubernetes and containers as a technology, one of the things that we kind of figured out very early on from our own personal growth and our own personal challenges with it is essentially it's hard to get right the amount of compute and memory you need to assign to an individual application, especially if you're doing that in a large cluster where you're having to manage 6,000-7,000 workloads, right? The easiest way to do that we have found is essentially most organizations will either let the application developers figure out exactly how much compute or memory they want to assign to a particular workload. And with my SRE background, whenever I was given that opportunity, it's like, okay, I'm just going to see how high this dial can go, because CPU and memory allocation to me means increased availability and reliability and performance, right? And if I don't have to pay the bill for it, even better. And then the inverse side of that, though, too, is the second way of running a Kubernetes installation is essentially you can just have a cookie cutter configuration deployment that you allow every single application to use. And the challenges with that one very quickly become either you have these big workloads that it's not enough, and so then you lose some performance and you lose some capabilities unless you come in and you automatically manually tweak those and tune them. But then you also have a majority of your workloads, 9 times out of 10, where it's just way too much compute. And so you're wasting compute resources, you're wasting power consumption, your cloud bill just goes through the roof. And we all know, and I think we've seen the cloud waste estimates out there where 50-60% of application teams and businesses are raising their hand and acknowledging that, yeah, we waste cloud compute because we over provision. And so that's what our system is designed to do. We have a patented machine learning algorithm that was written by its in-house data scientists that I've actually got 3 folks that have PhDs in applied mathematics that created this thing for us. That it goes through and it can look at the telemetry data that your application is already generating today and determine if that workload is either under provisioned or over provisioned, and then it can actually execute in an automated fashion to change that. So it's not like some of those other, call it, systems that are out there where they might flag things that are using a lot of compute, or maybe flag systems that have a lot of idle time. We will actually go out and we have the capability to crawl your entire cluster and make recommendations, and then specifically take action with the data that we get from your observability and telemetry to help you physically reduce your compute and your memory. So it's a really exciting time for us, especially with all of these enterprise organizations transitioning to Kubernetes. And as we all know, Kubernetes by design is designed to be flexible because it's completely open. So it's designed to allow you to migrate, your compute to quickly deploy into production. And it's designed to be automated. But in order to be able to take advantage of that, you really have to write some powerful automation that leans into that and makes it easy for your application team to leverage it. And so that's a big part of what we're trying to do, is to make sure that in an automated fashion, you're allocating the correct resources for every application.
So Patrick, where would you say that your key focus areas are for 2022 and beyond?
We've got a couple things coming up that are really excited, and I'm glad Ram is on the call here with me because I'm trying to figure out what I'm allowed to talk about or not talk about. I think I can generalize and say that by the time KubeCon happens this year, North America will have made a pretty big announcement on, I think I'll tease it by saying automated bidirectional scaling. And I think I can leave it at that. It's basically we're looking at, how do we continue to take it to the next step where we're helping application teams not only properly provision right out of the gate, but then in an automated fashion throughout the life cycle of your application, making sure that it continues to be provisioned correctly for your current demands. I'll say that.
All right. And since we're here today as part of the Mega Series, we're talking about Kubernetes management for DevOps and production workloads. How does your company define and approach Kubernetes management?
Yeah, so I kind of hinted on a little bit of that very early on, right? Like Kubernetes at its core is designed to make operators' lives easier. And it does that by essentially creating a super powerful capability that you can do a lot with when it comes to deploying your workload in an automated fashion, scaling your workloads, migrating your workloads from one data center to another cloud provider, migrating clusters. And it's only possible to be truly successful at that as if you have the right data in front of you and you know the actions that you're taking and you've written some pretty powerful automation to support that. So one of the things that we kind of tend to lean in on, and especially with my background as well, and from what I've seen in the past when I worked at the enterprise, is that you've got a really powerful tool that not everyone always knows how to leverage it correctly in order to get the most out of that tool and to really take advantage of the promise that is Kubernetes. It's almost infinitely in fact, it is, I would say, infinitely extendable, right? Like the SDK is out there. Anyone can write their own controller if they wanted to do some really tricky stuff with it. And that's essentially one of the things that we've done. So like when we talk about, management of DevOps and production workloads, for us, the piece that we focus on is making sure that you're taking the right intelligent action with the data that's in front of you as it relates to the amount of, compute and memory usage that you might need for an application that's running in production. And one of the ways that we do that is essentially through, like I said, looking at the observability data that you're collecting today. So whether you're using Prometheus, Datadog, Dynatrace, Honeycomb.io, New Relic, all of these tools do a really great job of collecting data for you. However, it's still up to the operators to make sure that they know what data is important to them, what they're looking at. And then once you have that observability, how do you turn that into actionability? Like, how do I know what to do with the data that's in front of me? And how do I know that my application workload is correctly scaled? How do I know that it has the right amount of compute, the right amount of memory? And 9 times out of 10, one of the things that we have found is that application teams tend to over provision to make sure that they don't have to answer that question. And so that's how we kind of approach our piece of the puzzle when it comes to Kubernetes management, is how do we extend the Kubernetes SDKs and the controllers that exist today to introduce automation that basically reduces toil from the application teams and the cluster operators so that they don't have to answer that question of what is the right level of compute and memory that I need to apply to this thing. And then a big part of it too is the configuration management. Whether you're an application owner or you're a cluster manager, eventually you get to a point where there are hundreds of configuration variables that you have to think about that all go into that question of what compute do I need and what memory do I need. If as human beings, we can kind of assess this by running performance tests and experimentation, right? Like we can change a couple variables within our application and run a performance test to figure out how much compute does it need, how much memory does it need, and how do these variables that I want to look at influence the decisions that I need to make as it relates to provisioning my application. The challenge that we run into that, though, as human beings is that we can literally only look at 4 variables at a time to draw relationships between them and then make a decision based on the results that we see in a performance test. And so that's why I firmly believe that this is one of those questions where machine learning actually helps a user significantly, and it's not just a buzzword, because we have a machine that can look at any number of variables that you deem that are important So like in a pre-production environment, for instance, if you're running Java, we can look at how you control heap. We can look at garbage collection. We can look at any variable that's available to us to manipulate, run experiments with that, figure out how they all relate together, and then produce what we believe is the perfect configuration set for the application, and then also what your Kubernetes deployment needs to look like as far as, CPU, memory, compute, all that fun stuff that goes into it once you get it into production.
You just finished talking a little bit about machine learning. What are some of the trends around Kubernetes automation and machine learning-based resource optimization that people should be aware of?
Yeah, the biggest trend right now that I've seen, and prior to being CTO of StormForge.io, I was actually a VP at United Health Group, and then prior to that, I worked at Best Buy, and I ran the site reliability engineering team for BestBuy.com. And if I had $1 for everybody that came to me at Optum and said, "Hey, I've got this machine learning thing," and it's like, okay, show me, right? Like, let me see what you're doing with that. And then they'd kind of pull the covers back a little bit, and I could look at it and just be like, that's a Holtz winter forecast. Like, I can do that in Excel today. That's not machine learning, right? Graphite has that built in as a function, and in fact, Grafana does as well. The biggest thing for me is making sure that when people talk about machine learning, it's not a buzzword. Like, they're actually talking about machine learning. And they can explain why machine learning is critical in the thing that they're trying to solve. They're not just throwing machine learning on because they want to be the next machine learning thing, right? It's very similar to me when we talk about like the original .com bubble in like the late 90s, early 2000s, right? You just add .com to your name and the value of your company goes up 100x. And same thing now, I think, with machine learning almost. And so there are very few use cases, I think, where machine learning truly causes a solution to be a differentiator, where something like like a Holtz winter forecast for anomaly detection could work just as well. And that's one of the things that prides us with what we do at StormForge, and especially as it relates to optimization. Because it's one thing to try to find and narrow down, like, how low can I get my CPU close to my actual usage to reduce cost? That's relatively easy to do. But when you start trying to throw in variables and have a system that actually understands the relationship between the variable dials that you're turning and what that does to your CPU usage, and then what the end result is for your request requirements and your limit requirements, that's something that machine learning is very well tuned for. And the big part of that too for us is being able to run experiments on your workloads, both in production or, more importantly, in pre-production as part of your CI/CD pipeline. Like, if you can run 100 experiments in a single evening, with 100 different variable configurations to where the machine has figured out how they all relate to each other and how that impacts how the code will run, and then it produces a perfect result that you can then take and deploy into production with, you can't replicate that with a human. And you certainly can't replicate it with a super basic linear regression that you're running just basic math against. So for me, the big thing is just be aware of machine learning as a buzzword. And anytime anybody talks about AI ops, like, take 2 steps back, right? Like, that's one of the things that enough people talk about it and they don't necessarily understand what that actually means, that it causes me just to it has a little bit of a sour taste in my mouth. There are people that are doing it really well when we talk about like Honeycomb.io and PagerDuty, for instance, where PagerDuty can naturally use machine learning to kind of bring causation and correlation into incident management, which is another really good example compared to somebody who says, "Oh, I've got machine learning anomaly detection." It's like, that's probably not machine learning if you're just looking at one statistic and identifying an anomalous portion of it. It's just, be careful who you're listening to and what they're talking about.
Now, as we're talking about your company and technology, what is it specifically about StormForge that sets you apart, differentiates you from your competitors? Why would someone prefer your offering to any of the others that are out there?
Yeah, so I guess the first thing I would say, and a rhetorical question, but could you name a competitor to StormForge, right? And I don't think you can today. I think we are the first to market in this particular area. There are plenty of competitors out there that are doing things like cost analysis for Kubernetes, which I think is really important, and it ties back to the business value. Because as a user, and especially as a CFO, for instance, I want to know which applications are spending the most money, because then I can tell somebody and maybe throw some humans at the problem to say, hey, go look at that application because they're spending a lot of compute. Do they really need to? Like, they're taking up a lot of resources. 60% of this particular node is that application. But it doesn't necessarily tell you if that application is justified in the configuration that they've deployed with, right? You can look at telemetry and observability data and make an assessment with that. But it still requires humans. And so when you want to do that 6,000, 7,000 times across a Kubernetes cluster, the human scalability problem becomes a very real challenge. And that's what StormForge does. And that's where we're different, because we don't tell you which of your applications are consuming the most resources. We don't tell you which applications are costing you the most on your cloud bill every month. What we do is we analyze your platform, whether you want to do that at a platform-wide level in an automated fashion, or you really want to hone in on your one critical application that you need to run experimentation on to get perfect. We will tell you how to configure that and how to reduce cost so you get that business value out of it, at the same time increasing the performance of your application, which is really unique to us as well. No one else out there is leveraging machine learning to be able to analyze those various variables or configuration flags that you can pull to try to figure out how to do both reduce cost and increase performance. And that's something that StormForge can do, and we do it every day in an automated fashion. In fact, we have a 30% guarantee on reducing your cloud bill, which is huge. It's massive. Like, there are customers out there that we're saving them millions of dollars a year, which is really exciting to me because I used to be that guy. In fact, when I interviewed with StormForge, one of the very first things I said was, holy cow, where were you a decade ago? Like, I need this in my life, right? And so that's something that we're really proud of. And that's something that, we're providing very real insight. And the other thing to me that's really interesting that differentiates us is that because it's machine learning, there's no human bias in it. One of the things that I like to talk about that made me a really great SRE is that I've broken a lot of stuff in my career. And so as a result, I know how to fix a lot of stuff because I've probably broken it before. And so I know how to roll that back, right? With our system, there's been more than one occasion where, like, perfect example, we tuned a Java application for somebody. And our machine made a recommendation to a garbage collection configuration. And the customer was like, that there's no way that would ever increase performance. Why would we do that? I was just like, you know what? I agree with you. I don't know why that would work either, but let's try it. Let's see what happens. And so we deployed it as a test into production. And sure enough, it reduced their performance in a significant way, which is awesome. So we not only decreased the cost for that particular application, but we actually increased the performance as the same result, which is really neat.
What does the future of Kubernetes environments look like, and how is your company influencing what's coming?
Yeah, that's a really great question. And that's one of those things where it's hard to say, right? I think Kubernetes, we're just starting to scratch the surface of what's possible. And especially as we look at the enterprise level, we're going to see enterprise organizations, like the ones that I've worked for in the past are hybrid, physical data center, private cloud in that data center, private cloud and public cloud data centers, and then hosted solutions like EKS and Google solutions and Azure and everything else. So I think that the future of Kubernetes is, like, the roadmap is long and it's wide of what comes next, right? I think the one thing, though, that is easy to answer is that we're going to continue to push the upper bounds of scalability with these platforms. And we're going to push the upper bounds of what can a human do to manage a cluster that's running like for instance, 7,000 workloads in it. I think I know that's a number that exists today in clusters out there at the enterprise level. And that's where an organization like ours comes in and can help influence and execute against those systems to better prepare and support the human beings that are behind it. Because that's the thing that I care about. And I've always held true to my SRE background in that we have to do everything that we can to reduce toil for human engineers, right? And this is one of those perfect use cases where the only real answers on how to address this problem are to either throw humans at it or throw a machine learning system at it that can I don't want to say outsmart the humans, but that can execute at a level that, maybe they can't because they're limited in their bandwidth every day to sit at a keyboard and look at just massive clusters to figure out how they can make it better, right? So that's one of the things that we're trying to help influence. And I kind of teased it a little bit earlier in the interview as well, but like we're going to have a pretty big announcement here leading up to KubeCon in North America in Detroit, where we will help not just with the optimization of your application as you get ready to deploy it, but like I said, the optimization of the application as it continues to run in an environment, both vertically and horizontally, so that we can do bi-dimensional scaling. Which is something where it's a perfect example, because if you have really smart humans, you can solve that problem today on an app by app basis. But if you don't and you try to solve that problem, like you can quickly run into thrashing issues and stuff like that. And so that's one of those things where a human can do well when they're hyper focused in a particular section of a cluster. But if you're trying to do this cluster wide for a capability, there's not enough humans in the world to throw at a cluster running 7,000 workloads on this. And so that's one of those things where we're hyper excited about this new capability that we're getting ready to unlock, and what that will mean for the humans that are the ones behind the scenes running these clusters, and how we can help them do their job more effectively.
Now, you've given us a lot of great information already, but would it be possible for us to see a demo of your solution?
Yeah, absolutely. I'd love to show you the platform as it exists today, and what capabilities we're offering, and what the data actually looks like, for sure.
Great.
Okay, so the StormForge application at its core consists of a platform that is essentially two products. So I talked a little bit about experimentation, and I also talked a little bit about observability. Those are the two things that we execute against in a way that allows us to essentially guarantee not only the application as you get ready to deploy it into production, but then also once you're in production, we can continue to verify the performance of that application, and we can leverage our tool set in order to make sure that you are essentially consistently running optimally, right? Then the way that we do that is kind of twofold. So we have, in fact, one of the things that we use this pet clinic demo. It's one of your typical like Google demos, right? So this is running on a cluster in our AWS, our EKS environment. One of the things that we look at is latency, for instance. Latency is one of those systems that's really important, or one of those metrics that's really important to customers. They say, I want my application to run as fast as possible. And in many cases at the enterprise today, this is one of those variables where they say, I don't care what it costs, right? Like, I will throw CPU and memory at this thing. Let's just get it running as quickly as we can. So here we have a result set of experiments that our tool has conducted. If we were human beings doing this, the way that you could think about each one of these little green dots is that this represents a performance test that was run, right? And so here we have, like just counting very quickly, probably 75 to 100. Actually, it should tell me, yep, 110. We did 150 total experiments. So imagine how long it would take an application team to run 150 performance tests. At my previous employer, where the really good teams were running it once a week, you're talking 3 years, right? This ran in a single evening. So we can do 3 years of experimentation worth of human toil in one evening, which is super exciting to me. And then out of the 150, we had 110 trials that were successful and 40 trials failed. And that 40 failed trials, what that means is our system attempted to conduct an experiment with a configuration set that wouldn't even launch. And so that's actually just as powerful to me, because we can tell you not only, hey, here's your optimal configuration for your application, but if you try to run it like this, don't even bother. Don't waste your time. It's not even going to start, right? So each one of these little green dots represents a experiment that we ran. So in this particular trial, this was trial number 140. It measured the P95 latency of just over 1 second at a reduced cost of 18% reduction compared to what the standard baseline was when we started. And so that baseline is this little blue dot. A really good way to think about it is this is what the customer started with when we came into town. So they were achieving 594 millisecond response on average. or P95th rather, with their performance tests, and it cost them, call it $14.50 per container. And so you'll notice as we look at the various parameters, so we look at like CPU, garbage collection, new versus survivor, code cache size, initialization, memory size, thread stack size. All these are directly over on top of each other because the results of the particular experiment always show the baseline with it. So you'll also notice these little white dots. These little white dots are what we consider to be optimal configurations depending on your personal thresholds. So for instance, if you care a lot about reducing your latency, but you don't really care about how much it costs, we could increase your cost by 2.5% and as a result, get a 75% reduction in your P95th latency, which is kind of interesting. We do that obviously by throwing more CPU at it, which you can see here. We actually reduce your garbage collection new ratio. We increase the survivor ratio. We increase the initial code cache size, decrease memory, and decrease thread stack. And then one of these, so all these little orange ones are basically optimal for that particular set, like I said. And then one of these, the orange one, is the one that we consider the right configuration to use. And so if you were to use this configuration, and this is one of the things that I talked about, we not only reduce the latency of the application by 66%, we also reduce your cost by over 15% for this particular app, which is kind of a mind-breaking thing for a lot of people, because normally you say to yourself, well, if I want to reduce latency, it's going to cost me more, right? But because we're using machine learning, that's actually not the case at all, which is really awesome. And so we can do this as part of like a CI/CD pipeline. We can do this in a lower environment in a regular automated fashion, and we can deploy the configuration for you if you plug us into your deployment pipeline, for instance, which is really neat. I'm a big fan of this tool. Like it's really exciting to me. As part of that, we actually, so that's the pre-environment Optimize Pro. We also have a capability called Optimize Live. Optimize Live is the exact same thing, except rather than running experiments to artificially increase load, which is what a performance engineering test is, we monitor your observability pipeline in real time in production. With Optimize Live, because that is collecting real data from your environment, we actually don't ship that out of your environment. So that observability data stays within your cluster. So as a result, what we do is we actually drop a little tiny time series database in your cluster, in your application workload space, so that we can keep all of the data there, which is what this here is. And then we spin up an Optimize Live. It's a dashboard in Grafana, essentially, is all it is. And this says it's running on localhost, because I'm essentially using a kubectl proxy that forwards my localhost port 3000 to the localhost or the server in the EKS environment where this particular cluster lives. And so this one is really neat because it not only shows you where you're at today for your current, like for instance, your server, your CPU limits and requests, and your memory limits and requests, but it also shows you your usage, because we're just, like I said, we're piping your standard telemetry. So in this case, like your CPU usage. And then you can actually visualize what our recommendation is. And so here we have the green line is the limits for this particular server. This is, again, a pretty standard microservices demo. What it is, it's multiple workloads in a microservice environment. I just have the front end one selected here. And then what we're doing is our system is saying, our system is the tolerance level here. Those are the recommendation that it's making. For live, we actually give you 3 options for risk tolerance, depending on the application. So if this is an application where, like with CPU, for instance, if you spend more CPU than your application is allocated, then you run into throttling. It's not going to kill the container, but a certain percentage of your application customers might be throttled. They might have to wait a little bit longer. If it's a non-priority application, you can actually tell it, hey, I want to be high with my CPU recommendations. I have a high tolerance for pain here, so we can crank that up, right? But what we can do is we can say, hey, if you have a high tolerance for pain, we can get aggressive with this. So if your actual usage is 300 millicores, then we'll recommend 401 millicores. So we'd still have that 20% buffer in there. And then on top of that, we're going to reduce your limits pretty significantly. The limits here are set to 481 millicore. These calculations run every 5 minutes. And then as part of that, you can set the deployment process, whether you want to manually deploy these by clicking approve, or you want to automate the deployment by either integrating this with your CI/CD pipeline, or you can even extend. So our controller goes directly into your cluster. Like I said, all of this is local on the actual workload itself that we're doing these calculations on. So you can give our controller permissions to actually automatically make these adjustments for you. Like the best way to describe it would be a really, really, really smart version of the VPA, right? Like we essentially replace the VPA and do it on our own. I think everybody knows that the secret to the call it the success, or the what I like to call the wonderfulness that is Kubernetes, is your ability to be flexible. It's really important that you follow your usage curves as quietly and closely as you can, so that you're maximizing your cost savings by reducing your compute needs when the traffic's not there, right? And so that's what we enable you to do in live. And if you combine the platform of Pro with live, then we're launching you into production with the right settings from the very beginning. And then with live, essentially, we're acting as a really just, it does it a disservice, I think, to describe it as a VPA, but it's basically a VPA on steroids to the nth degree, right? So it's really powerful, and it really helps to not only maximize your reliability and your performance, but like I said, at the same time, reduce cost, which is just that's the magic thing for me.
So Patrick, thanks for that great demo. Where can people go if they want to find out more information about StormForge and some of the stuff that you've talked about today?
Absolutely. So you can obviously find us at stormforge.io. And there we actually do have a link at the top where you can get a demo, or actually even request a free trial. So feel free to hit those forms, and then we'll reach out and configure and do a free POC and a free demo for you. And then if you're going to be at KubeCon, we are going to have a booth at KubeCon North America in Detroit. I'll be there manning the booth, and I would love to talk performance engineering, SRE, machine learning optimization, like any of these fun, super deep topics with anybody that wants to swing by.
Great. Well, thanks for taking the time to speak with VMblog today, and for being part of our mega series.
Absolutely my pleasure. Thanks so much for having me.
All right. Thank you.